So this is 5.2a in college trigonometry, verifying trigonometric identities. So what that means when I say verifying trigonometric identities, it means that you're going to prove that something is equal to something. So, for example, if I say that the cotangent of s plus 1 equals the cosecant of s times the cosecant or cosine of s plus the sine of s. So what I'm saying is that these two are equal to each other. And what you're doing is you're proving that that's a true statement. So there are some methods in order to do this to make it easier. And one is to become familiar with these, that you can get to them pretty quick and easily in order to use those to help you. The next thing you try to do is you look and find out which of the sides of the equal sign is the most complicated. So like this one here. And you're going to work with that first, and you're going to try to do things to the complicated side to make it equal to the simpler side. And then one of the other things that's really helpful is if you can set this all up so all you have is sines and cosines, that makes it easier. So if you can use those few clues, and I got those from page 189, that's going to help you as far as figuring this out. Alright, so again, one of the things that I like to do is try to get these things to look more like sine and cosine. So I'm going to take my cosecant of s right here, and I know my cosecant of s is the same as 1 over the sine of s. So now I just got rid of the cosecant and made it into a sine. That makes it kind of nice. Alright, let's see what else we can do here. I'm going to go ahead and distribute the sine right here. So I'll have cosine of s over sine of s plus sine of s over sine of s. Anything over itself is 1. Cosine over sine is cotangent. Oops. So I just took this huge mess right here and made it right into that there. Alright, so let's look at the left-hand side. I've got cotangent. Whoa, they look the same. I just showed that they were both equal to each other. That's it. Okay, so for this one we're going to work with the more complicated side right here. And we're going to take that and just kind of not even worry about it. So let's just kind of leave the right-hand side alone. Let's use distributive property. Okay, and I do know that the cotangent from right here is 1 over tangent. Okay, multiply those together, I get tangent squared of x over tangent squared of x, which equals 1. Okay. Now, one of the things I know from, let's see, where is it? Right here. Tangent squared of x plus 1 equals secant squared of x. Alright, so I've got secant squared of x. I'm trying to make it look like that. Alright, so I'm going to erase all that blue there, and I've got it down to the secant squared of x. So this whole left side is now secant squared of x. So where I'm at now is I'm trying to get that secant to turn into a sine. So what do I know about secants and sines and cosines? I know that the secant is 1 over cosine, so it's going to be 1 over cosine squared of x. So let's stop for a minute and see what we've got. We've got a cosine squared of x and a 1 minus sine squared of x. If we take our Pythagorean theorem here, I can rewrite this in terms of cosine as cosine squared of theta equals 1 minus sine squared of theta, right? Okay? And I just said cosine squared of theta, 1 minus sine squared of theta. The only difference is they're both under 1s, but that doesn't matter. If this denominator is equal to this denominator, and this is a 1 and this is a 1, then they're both equal to each other. So I'm done. Alright, let's jump over to example 3. Okay, so this is example number 3, and I've got tangent minus cotangent over sine of t cosine of t, and I've got that equal to secant squared t minus cosecant squared t. So what I'm going to try to do, I'm going to look at my more complicated side, and I'm going to try to transform that so it looks like this side over here. This is a problem right here, this minus, all in one fraction. So what I'm going to do is I'm going to split those two up. I'm going to write this as tangent of t over sine of t cosine of t. I'm just going to write sine and cosine. I get so tired of writing the t all the time. Okay, and sine, cosine. Alright, and then I'm not even going to write that. I'm just going to come back to that later. Alright, so now I split them up. Now remember earlier I said if you can make these equal to sine and cosines, it's that much better. So I'm going to take this tangent and this cosine. I'm going to pull them out. And I'll show you what I did that for in a minute. So multiply 1 over, because I can write my tangent then as sine over cosine, and my cotangent I can write as cosine over sine, like that. Now it looks messier, but the reality of it is I just got rid of all my sines and all of my tangents and my cotangents. So in actuality, that kind of makes life a little bit easier. And here's another cool thing. I can cancel that and that and that and that. And when I do that, I have 1 over cosine squared of t minus 1 over sine squared of t. So I have that. Okay, I'm going to see if I can get rid of everything except what I have boxed in red there. So what I'm saying here is that this is equal to this. Alright, so now let's see if we can compare this with this and be done with it. Alright, what do we know about 1 over cosine squared of t? 1 over, okay, it equals the secant. Okay, what do we know about 1 over sine? It equals, it equals the cosecant. So minus cosecant squared of theta. Alright, so holy smokes, look at that. That equals what we're looking for. So I just verified that that works. Alright, so one more example. Okay, so notice on the hints for verifying identities on 109, number 6 says, if the expression contains 1 plus the sine of x, multiplying both the numerator and denominator by 1 minus the sine of x would give 1 minus the sine squared of x, which could be replaced with the cosine squared of x. Alright, so we're going to use that in this one here. We're going to multiply the top and bottom, put it in red here so you can see 1 minus sine of x over, you do on the top, you do on the bottom. Okay? And what we get then when we do that is 1 minus sine squared of x, because we're going to use the FOIL method there. And we get that, 1 minus the sine squared of x. And on the bottom, we're going to get cosine of x times 1 minus sine of x. We didn't combine those at all. Okay, so we end up getting that, and that looks a little bit better. What do we know about 1 minus the sine squared of x? Well, if we go up here, we know that equals the cosine. Cosine squared of x over, and the only reason we did that is because I've got some canceling I can do then. So I can cancel one of these with this one. And now I have as an answer cosine of x over 1 minus the sine of x. And if you look at the left-hand side of the problem, right there, that's what we were trying to get it to verify with. So we worked on the right-hand side until we got this, and then looked back at this and noticed that it was the same thing. Alright, so that's example 4. One more video on a couple of other examples with a different method and we'll be done.